our last class was cut short because of some technical problem. So we will continue from there. Okay. I hope if I totally recall, I gave you 2 questions for the homework. So I will start with that question. So in the last class, what we will do? What we have done in the last class, we have done the symmetrical concept to find out the equivalent resistance or in a symmetrical network. Okay. So I have gave you some steps to follow, and if you follow that steps, each and every question of symmetrical concept will solve easily. Okay. So if I remember, I gave you this one question in the homework. So tell me, have you done homework or not? In this question, we have to find out resistance between two terminals AF. So one option of this is 3R by 5. Okay, fine. So we will solve this question. So this is a question of symmetry. Why? First of all, we have to check whether this question is of symmetry or not. For that, we have to draw either vertical line or a horizontal line. Okay. So I am drawing a vertical line, just I have done earlier. Okay, this is a vertical line. Now you can see, according with respect to this line, you will get a mirror image on this side, as well as you will get a mirror image on this side. Yes or no? Okay. So that means this is a line of symmetry. Next step is to identify the line of symmetry. For identify the line of symmetry, we have to draw the axis of symmetry. And what is the axis? The terminals, the line connecting the terminals between which we have to find out the equivalent resistance, like this. This is F, this is A. So you have seen, now you have seen that the axis as well as line of symmetry, both are parallel to each other. That means this is a parallel line of symmetry. This is a parallel line of symmetry. Second step finished. Third step, now for a parallel line of symmetry, the branches which are perpendicular to it contain equipotential points, and for perpendicular line of symmetry, the branches which are parallel or on it contain equipotential points. So here I have seen this is a parallel line of symmetry. So branches which are perpendicular to it contain equipotential points. So tell me, what are the equipotential points here? Tell me, what are the equipotential points here? Okay, DE and BC. So here you can see the branch DE and the branch BC are perpendicular to the line of symmetry. So here I can say D comma E and B comma C are equipotential points. Now I have an equipotential point. Now I can either short circuit this branch or open circuit this branch. So I am doing the open circuit. So open circuit the branch DE and BC. So I am open circuiting the branch DE and BC. The network will look like this. And this is the axis. This is F, this is A. Okay, so the network will look like this. Now we have to find out the equivalent resistance. So you can see this resistor, these three resistors are in series, right? Similarly, these three resistors, these are again in series. Again, it can add up. Okay, so I have a 2 point. One is A, one is F. Okay, so these three resistors are in series. I can write the sum like 3R. These three resistors are in series, so I can write 3R. Okay, now see this resistor, this middle one, it is between A and F. So again one resistor R, and finally this series branches, again I can write 3R. Okay, so now we have to find out resistance between AF. So for resistance between AF, all resistors are parallel, so I can write 1 upon 3R plus 1 upon 3R plus 1 upon R. So by solving this, you will get RAF equal to 3R divided by 5 ohm. So this is the resistance 3R divided by 5 ohm. So students, this was a question that I have given you in a homework in the last class. So there was doubt earlier for one student, I don't remember the name, that we can solve this question from star delta also. So the question that we have solved earlier in last class, resistance between DC, that question can be solved using the star delta transformation. But if you want to find out resistance between AF, like this question, then you cannot solve it using the star delta. Because in star delta, what happened? The terminals across which you have to find out the resistance, you cannot change that terminal. What does it mean? I will explain it when we will go to the star delta. Right now we are completing our symmetry concept. So this was the question I gave in homework, and also one more question I have given you in homework. So tell me the answer of that question. Now try to solve this question. In this question, we have a network given and we have to find out voltage AB. This is a node A, this is a node B. And 1 ampere current is entering from the node A. So in this, we have to find out voltage AB. Carefully do this question from the starting. Don't skip any step. Step 1, step 2, step 3, step 4. Okay. For every theorem, for every analysis, I will give you the step. So whenever you do practice questions, do all steps in that question. Even though you know, don't skip any step. But in exam, you can skip the steps to save the time. But during practice, don't skip any step. Okay? Otherwise, in exam, you got confused. So here, the first step was to see whether we can apply symmetry concept, yes or no. Okay, so tell me, can we apply symmetry concept here? Yes or no? Let's see. We can or we cannot. So let's see. First of all, we have to draw the line of symmetry. Okay, line of symmetry means which divide the network into two equal parts, or I say into two mirror image. So I can either draw vertical line or I can either draw horizontal line. In both the lines, it will divide the network into two mirror image part like this. I have drawn this network like this. Now see, above this line and below this line, we have a mirror image. So I can say this is our line of symmetry. Okay, I can say this is our line of symmetry. First step complete. Okay, now second step, we have to draw the axis of symmetry and identify the line of symmetry. Either it can be parallel or perpendicular. Okay, axis means we have to join two terminals across which we have to find out the equivalent resistance. See, question was that we have to find out the voltage AB. Okay, so voltage AB, and they have given you one current 1 ampere. So if I know the resistance AB somehow, if I know the resistance AB, then voltage AB will be resistance AB multiplied by 1. That's why we are finding out resistance here. Otherwise, what will happen? You have to divide that current in each and every branch by using KCL. Then you will apply the KVL. The one question that we have done in earlier classes. Okay. So see here, we have to find out voltage AB. So for that, we have to find out resistance between AB. Now I am drawing the axis of network. Like this. This is my axis of network. So tell me, what kind of line of symmetry is this? Parallel or perpendicular? Perpendicular, first option. Okay. Anyone else? Now, this is the mistake generally people do. Perpendicular, how can you say that this line is a perpendicular? You can see there is some angle made between them, angle theta. There is some angle made between them. We cannot say this line is a perpendicular. Okay, but now next, neither perpendicular nor parallel. Correct. See, first point you have to remember in a symmetry concept. Never change the configuration of the diagram given in a question. For example, some people will do what? They will make diagram like this. That I can redraw diagram like this somehow, and something above. So they will do this point will be B and this point will be A, and then they will combine the line and say this is a perpendicular. So first point to apply symmetry, or I can say limitation to apply symmetry, never change the configuration of a network given in a question. And if I am not changing the configuration given in a question, then you can see this line of symmetry, neither perpendicular nor parallel to the axis of symmetry, axis of a network. So I can say this question cannot solve using the symmetrical concept, because symmetrical concept we cannot change the configuration. That is the limitation. That's why in a practical life, like in hospital, in home, or the big industries, we cannot use this method, because in big industries or houses or hospital, the configuration is fixed. You cannot change the configuration. Even the network is symmetrical. For example, this network is symmetrical, no doubt. Why it is symmetrical? Because by drawing the line of symmetry, two mirror images coming. This network is symmetrical, no doubt. But because of the axis, we cannot get the line of symmetry. Okay? So this question cannot solve using the symmetrical concept. The only method to solve this question is the star delta transformation. So when we will do the star delta transformation, I will come again on this question. Okay? So guys, remember this point. For applying the symmetry concept, never change the configuration. Okay? First point to remember for symmetry. Second point to remember, we cannot apply symmetry twice in a network. For example, I'm applying symmetry one time, then I'm redrawing the network, then I'm again applying a symmetry concept or a symmetrical line. That will be wrong. Second point to remember, we will never apply symmetrical concept twice in a same question. Okay, got it? Third important point, if we change the axis, equipotential point will change. For example, in last class we have done one question like this, this one. I am again drawing this question. This was A, this was B, this was C, D, E, F. So in our last class, the axis was BC, which means we had to find out the system in BC. So for BC axis was BC. For the BC axis, tell me what were the equipotential points? For BC axis, the equipotential points were, I'm changing this. This was the F, this is D, this is E. So tell me, for BC, for axis BC, what were the equipotential points? Tell me quickly. What were the equipotential point? AF, correct. So in yesterday's class or in our last lecture, we have seen that for BC, equipotential points were AF. Now, in today's class, we have seen for axis AF. When the axis AF, what were the equipotential points? DE and BC. So you can say the network is same, but the equipotential points are changing. Why? Because equipotential points depend on the axis of a network. Remember this point. Okay? But equipotential points are independent of the line of symmetry. What does it mean? It means you can draw either a perpendicular line of symmetry or parallel line of symmetry. For a particular axis, equipotential point remains same. Okay? The same thing we have seen earlier. For example, I'm again drawing one question that I have given you in homework. In homework, I gave you one question, this one. Okay? And right now, I'm fixing my axis is AF. Okay? Between AF, we have to find out the resistance. Okay? So, this was a question that I have given in the homework. So, for a AF, this network. For this network, I can draw vertical line so that this is a line of symmetry, or I can also draw horizontal line. This is also a line of symmetry. So you can see, if I'm talking about this line of symmetry, blue one, this is what? This is parallel line of symmetry because it is parallel to the axis. If I talk about this one, red one, this is what? Perpendicular line of symmetry. Okay, I have drawn both line of symmetry, parallel and perpendicular. Now see, if I see parallel line of symmetry and now I am asking what is the equipotential points. So you can see for a parallel line of symmetry, the branches which are perpendicular to it. So for this parallel line of symmetry, branch BC and DE are perpendicular to it. So for this, equipotential points are BC and DE. These are the equipotential pairs, right? Now if I see for the perpendicular line of symmetry, so see for a perpendicular line of symmetry, the branches which are parallel to it contain equipotential points. So branches which are parallel to it are BC and DE. So again, for this, the equipotential points are BC and DE. So equipotential points depends on the axis. It does not depend on the type of line of symmetry. For a particular axis, the equipotential points remain same. Got it? Yes or no? If you have any doubt, ask me. Which question you are referring? There were two questions here. One question was this. Are you referring to this question or some other question? What you are saying that they were not the mirror image of each other. Why not they are mirror image of each other? I am drawing line in middle of it. So you can say the same configurations above the line and the same configurations below the line, and the value of all resistors are equal, like this. That's why this network is a symmetrical network. But because of the line of symmetry, you can see this is a line of symmetry, but if I draw the axis, that axis is not giving me any parallel or a perpendicular axis. That's why we cannot solve this using a symmetrical concept, because we have only two type of line of symmetry, parallel or perpendicular. Okay, fine. So this was a question of the line of symmetry, and this topic is important for this year because I feel that they will ask you question on symmetry. Fine. Now we will go some one more small topic about 3D figures. How to find out resistance or a total component or a inductance, anything for a 3D figure. 3D figure is like cuboid. Okay, that is a practical life figures. Now the case is a 3D figure. Okay, so before directly going to 3D figure, I will explain you some concepts. Then we will see the 3D figure. So for the 2D figures that we have seen in 2 or 3 questions, what we have done? We draw the line of symmetry and axis of symmetry and then proceed in that way. So for a 2D figure, we used the line of symmetry. But for the 3D figure, we use the plane of symmetry. Okay? What is the point? That for 3D figure, we use the plane of symmetry. But by using the plane of symmetry, it will be a typical method plus it will be a lengthy method. And even more, this method is not in your GATE syllabus. Even for the other government exam, that use plane of symmetry to solve the 3D figures. Okay, that's why we will not do the plane of symmetry. We will do it by using the concept of equipotential points. Okay, in line of symmetry also, we did find the equipotential points and then we redraw the network. Here, we will also find out the equipotential points and then redraw the network in such a way that 3D figure will convert into a 2D figure. But here, the procedure of finding out equipotential points will be different as compared to 2D figure. Okay? So before explaining the procedure, see one thing. Let us suppose I have a 2 points. I have a 2 point A, B and 2 points more C and D. These 2 points are origin, these 2 points are destination. Okay? Got it? This is origin, this is destination. I have an electron. Again, this is me, one electron, this is my friend, second electron. Okay? Now, the work of this electron is to go from one origin point to one destination point. Okay. So let us suppose this electron is going from A to C. And by going from A to C, it is using some amount of energy. Let us suppose that amount of energy is J1. Okay. Similarly, my friend also, which is at point B, is going from B to a particular point C. From B to a particular point C, and again it used some energy, let us suppose J1. Okay. Now, after some days, this A is, now electron 1 is going from A to D using the energy J2, but electron from B goes to D by using different energy J3. It means what? That an electron is going from point A to a particular point C, from A and from B, and using the same amount of energy. But for going to D, it is using a different amount of energy. A is using the J2, B is using the J3. It means if I choose any different point, again there will be a difference in the energy from point A and from point B. So if there is a difference in the energy take place, then these points are not equipotential points. What did I say? See, if the energy taken by electron from going from origin to a destination point are equal, if energy taken by electron from different origin point to a different destination point are equal, then that origin point is a equipotential points. Means you are using the same amount of energy, either you are going from A or you are going from B. And also it is not depending on a destination. Means it's not depending on you are going on C or D. You are using the same amount of energy to reach either C or D from point A or B. So if this condition satisfied, then we can say that A and B are the equipotential points. And if they are the equipotential points, we can either short circuit it or open circuit it. So in this 3D figure, we use the concept of resistance as a distance. We will assume that resistance taken by an electron to reach a particular point is equal to the distance taken by electron to reach that point. And if distance taken by both from two position to a particular point is same, then it will be a equipotential points. Okay, so see, the concept is simple. Just remember one thing, we will assume that resistance is nothing but a distance taken by an electron. Okay, so first of all, I am drawing one 3D figure. I am drawing one 3D figure. Okay, and for 3D figure right now, I am drawing the cube. Okay, so I am at a cube. This is a point A, B, C, D, E, F, G, H, and all resistors are equal. And all resistors are equal. Now, in this, three type of question can come. First type of question come, find out total resistance between adjacent node. Total resistance between adjacent node. Adjacent node, you can take any two nodes which are adjacent. I can take AB, or I can take BF, or I can take CG, any point. So here I am taking, first we have to find out resistance between AB. Okay, this adjacent node. Second, total resistance between diagonal of a face. Total resistance between diagonal of a face. So in a cube, we have 6 faces. Okay, front, back, top, bottom, and 2 side faces. So we have 6 faces. So out of 6 faces, I can choose any diagonal. Why? Because it is a symmetrical image. Okay, it is a symmetrical. You can see from this side, or you can see from top or below. The image is symmetrical, so you can choose either face. So let us suppose I am choosing the front face. So for a front face, we have to find out resistance between AC. Okay. Third question is total resistance between diagonal of Q. See, first point was the diagonal of face. The next is a diagonal of a cube. Diagonal of a cube is what? Just like from point A to point G or to point H to point B. So here I am taking only one diagonal, which is RAG. So we have to solve these three type of question. Okay. Up how to solve this question, that we will going to see. So first of all, I told you that assume the resistance is as a distance. Okay. So first question we are going to solve. We have to find the resistance AB. We have to find the resistance AB. To find the resistance in a 3D figure, we have to draw one table. What is the table? In table, first row contain the points between which you have to find the resistance. Okay. And then there is a remaining point. C, D, E, F, G, H. C, D, E, F, G, H. Now you have to calculate the shortest distance to move from this point to these points. But we have to calculate the shortest distance taken by electron to move from point this A and B to these points. Okay, got it? So see, first I am talking about the point C and I am talking the shortest distance taken by electron, because if I am going from A to C, I have many ways. I can go from A, E, F, G and C, or I can go A, B, C, right? But we have to choose the shortest distance. So see here, and one more point. Never take a distance like this, that I am going in a diagonal form, because electron cannot flow in air. Electron can only flow in a wire. So this cube actually contains wires, right? So electron can only flow in a wire. They cannot flow in air. That you can say root 2 times of side, right? So I am going from A to C. So the shortest distance will be, I can go from A to D and then C, or I can go from A to B and then C. Both are equal. So you can see this is R, this is R, 2R. It means I have take 2R unit distance to reach the C. Okay. Again I am telling you, assume resistance as a distance. So R, how much distance? 2R. From B, the shortest distance to reach C is R. Again, now for point D. For point D, the shortest distance from A is R. From B, it is 2R. For point E, the shortest distance is R from A, and from B, it is R plus R, 2R. From point F, the shortest distance to A is again 2R. From B, it is R. Now for G, for point G is here. The shortest distance from A is, we have to go to D, then H, then G, which means R plus R plus R, 3R. From B, we have a R and R, 2R. Now to H, from A, we have R plus R, 2R. From B, we have R plus R plus R, 3R. Okay. So carefully see, we have taken the shorter distance and we have created a table like this. Okay. So tell me, you got it, how to create a table? First tell me this. We have taken resistance as a distance. Okay, and choose the shortest distance for electron. And always remember, don't take diagonal as a distance, because it is an air there or vacuum there. Okay. Now after creating the table, we have to choose those rows which are equal, which are symmetrical. Okay, you can see row D and row E are symmetrical. You can see if I am at A or if I am at B, to reach D and to reach E, I will spend the same amount of energy, right? Because the obstacle or the resistance is same. So you can see point D and E are equal from point A and B. It means D and E are the equipotential points. Which means after creating the table, select those rows which are equal. And that row become the equipotential points. So tell me, apart from DE, there is also some other pair? Yes or no? Apart from DE, is there any other pair? CF. Correct. Apart from DE, I have another pair which is CF. It means till now I am getting a two pair. It means C comma F and D comma E are equipotential points. So students, in 2D figure, we use the line of symmetry to find out the equipotential points. But here, we use the resistance as a distance method to find out the equipotential points. Okay, in both the methods, 2D and this 3D, the main objective is to find out the equipotential points. Okay, so we have find out the equipotential points here. Okay, we have two equipotential points. Now, next step is to redraw the diagram. Now, in redraw the diagram, we can either open circuit or short circuit the branch, right? Now see here, D, E and CF. D, E and CF both are pair of equipotential points. And you can see there is not any branch present between them. It means I can assume they are actually open circuit. So if they are already in an open circuit and the network is in complex form, so now I can only short circuit these 2 points. Okay, they are already in an open circuit given the network, but the network is in a complex form. So now I can only short circuit these points. And what is the meaning of short circuit in symmetry? I told you, if 2 points are short circuit, bring 2 points and make it up one point. Okay, so now we will redraw the diagram. So see carefully. D, E and CF are equipotential points. So what I am doing, first I have taken the point A and the point B between which we have to find the resistance. Now D, E, I am taking a 1 point and the name of this point is D comma E. Here also I took 1 point and the name is CF because I have short circuit these 2 points, and short circuit means bringing the 2 nodes and making it a 1 node. And the remaining points are, you can put it here H, you can put it here G. Okay. Now we have to draw all the resistance here. Okay. So see here and carefully draw the resistance. Don't leave any branch, otherwise the whole question will be wrong. So you can see from node A, I have 3 branches. 1 towards E, 1 towards D, 1 towards B. 3 branches to B, D, E. So from A, I have a 1 branch to B, 1 branch to D, and 1 branch to E. Like this, 3 resistors, which means this one is complete. From D, I have 1 branch to C and 1 branch to H. From D, I have 1 branch to C and 1 branch to H. It means this 2 is complete. From H, I have 1 towards G and 1 towards E. From H, I have 1 towards G and 1 towards E. Both points are same, that's why it will be a parallel. So this one also complete. From G again, I have 1 towards C and 1 towards F. From G, I have 1 towards C and 1 towards F. Like this. Now you can see from B, I have 1 towards C and 1 towards F. Like this. Now in a cube, we have how many branches here? We have 12 branches, so 12 resistance must be here. So we can calculate it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means 2 resistance are remaining. Which one? you can see from E to F there is a one resistance remaining, and from E to F, sorry, right, from E to F. So how much? How many? 1, 2, 3, 4, 5, 6. Okay. We got a 12 resistors here. Okay. Have you understood how to draw this diagram? Yes or no? Tell me. Okay. So we have seen that this was a 3D figure, but we have changed this 3D figure into a 2D figure. Okay, this was a 3D figure. We cannot calculate directly resistance in a 3D figure. We have changed it into a 2D figure. Okay. Now we can solve this, and this is a simpler one. You can see these two are in parallel. These two are in parallel. So it become R by 2. This is also parallel. This become R by 2. This become R by 2. R by 2. R by 2. Right? Okay. Now this R by 2, this R and this R by 2 are in series. So R by 2 plus R by 2 gives you 2R. Similarly, so I will draw network again. This become 2R. So this become 2R. This become R by 2. This is also become R by 2. This is also become R by 2. Now 2R and R by 2 are in parallel. So if these are in parallel, you can write 2R multiplied by R by 2 upon 2R plus R by 2. So we can solve it. 2R divided by 5. So the parallel combination will give you 2R divided by 5. Right? So then 2R by 5, this R by 2, this R by 2 are in series. So I can write R dash is equal to 2R by 5 plus R by 2 plus R by 2. Right? It will give you 7R by 5. Check the calculation also. This will give you 7R by 5. It means now the network is simplified into this 7R by 5. Okay, and this is R. Now you can simply write RAB is equal to 7R by 5 multiplied by R, 7R by 5 plus R. It will give you how much? 7 by 12R. This is the answer. So in here we didn't use the plane of symmetry. We just take resistance as a distance and find out the equipotential points, and then just we have to redraw the network. Okay, got it? Yes or no?